we are going to know new point, that is topic in the transition and inner transition. So first we see the transition element part. Now the see next new point, inner transition. Elements which are also known as F block elements. F block elements. So the first we see its position. Position of F block element which are placed bottom of periodic table. Second, they are present in third and fourth group. Present, not present between. Present between third and fourth group. Which are also present in 6th and 7th period. So position is 6th and 7th period. They are placed but present between 3rd and 4th group. They have 14 elements between 3rd and 4th group which are placed bottom of the periodic table. Last electron entering in n-2 F subshell. n-2, that means n is last shell, n-1 last second shell, and n-2 that means last third shell. So last electron, that means valence electron placed in last third subshell of F subshell. Last third shell or F subshell. Okay? Its electronic configuration like first is n-2 F subshell which have 1 to 14 electrons. Next is n-1 D subshell which have 0 to 2 electron, and last is ns having 2 electron. So that is the general electronic configuration of F subshell, F block elements or inner transition element. Here, previously we studied the transition element are known as Y transition because they place between S block and T blocks. So that are called transition element. But these elements are placed in the transition element, so they are known as inner transition elements. Because placed in between transition elements. So that is the position of a block elements. Now the next see properties of inner transition elements. So the next first place between n-1 d block, that means transition, and near about ns block, that means s block, d block and s block, near about between d block and s block. Last electron added to F subshell, the previously explained, with F subshell, added in F subshell, but with n-2 level, n-2 level, and their properties are similar to D block elements or transition elements. Their properties are similar to transition elements. They are also known as rare earth elements because they are found on earth in very small quantities, fairly abundant on earth crust. So they are also known as rare earth element. Okay. Now the next, these F block elements can be classified into two series. First is lanthanoids, the second is actinoids. Lanthanoids and actinoids. Lanthanoids means which series start after lanthanum, so they are known as lanthanoid, which having also 14 elements. Similarly, they start after actinium, and there are also 14 elements. Here, the position in group similar, third and fourth group. They both have present between third and fourth group, but in period they are different, which place in sixth period, but they are placed in seventh period. Its general electronic configuration is 4f 1 to 14, 5d 0 to 2, 6s 2. Last subshell is 6, so that is placed in 6th period. And for actinoid, the general electronic configuration is 5f 1 to 14, 6d 0 to 2, 7s 2. So last shell is 7, so they are placed in 7th period. Both having 14 elements. Next is elements in lanthanoid, starting with cerium 58 to lutetium 71. Okay, elements are 14 present in lanthanoid. And for actinoid, starting element is thorium 90 to last element lawrencium 103. So here 14 element present in actinoids. So that is the difference between lanthanoid and actinoid, and also we see position of lanthanoid and position of actinoids. We now start with the new point, electronic configuration of lanthanoid series. So we see element, atomic symbol, atomic number, their expected electronic configuration, and the last is observed and actual electronic configuration. So we now start with the series of element First element is lanthanum. It is not actually part of lanthanoid series, but we start with the lanthanum. After that, the element in lanthanoid first is cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and the last is lutetium. Now the next, their atomic symbol are La, C, Pr, Nd, Pm, Sm, Eu, Gd, Tb, Dy, Ho, Pr, Tn, Yb, and lutetium. Their atomic number are 57, 58, 50, 60, 61, 62, 64, 65, 66, 67, 68, 69, 70 and 71. Now the next is expected electronic configuration. So the first electronic configuration of lanthanum is Xe 4f0 5d1 6s2. Here the last electron entering in 5d, but from cerium, as expected, all the electrons are present in 4f section. So the next is as manner with 4f1, because atomic number increases by 1, that means only one extra electron added in it. So the 4f2 5d1 6s2. But as accepted, the electron present in only in 4f section. So one electron can be placed in 4f. So that means 4f2 6s2. As next is 4f3 6s2. 4f4 6s2. 4f5 6s2. 4f6 6s2. 4f7 6s2. 4f8 6s2. 4f9 6s2. 4f10 6s2. Only one electron added in 4f section, not changing other section. 11 6s2. The last is Xe 4f14 5d1 and 6s2. because 4f14, 4f subshell is totally fulfilled, but still one electron remains, so that present in 5d subshell. So that is expected electronic configuration. Now the next is observed electronic configuration. Observed electronic configuration is change in some cases as like d block element or transition element for half-filled and fulfilled condition. For example, the first is similar because this is not a part of inner transition element or d block element, so the electronic configuration is similar. For second, only the first case is exceptional. Only one electron present in 4f, next is 5d1 and 6d. After that, the electronic configuration is similar to expected electronic configuration. Observed electronic configuration and expected are similar. Here half-filled condition given, but after that also half-filled condition given with extra electron. At the 7 electron, your subshell is half-filled, but one extra electron can be shifted into 5d to get again half-filled condition. So that is the exception case. After that, similar 4f9, 6s2, 4f10, 6s2, 4f11, 6s2, here no change. Last is XE, 4f14, 5d1, 6s2. So only two cases which have changes. Otherwise, all cases are similar to expected electronic configuration. So this is the electronic configuration of lanthanoid cells.